Okay, so you're already an expert on ionic bonding. And so if you happen to be, we had said that depending on who you are, depending on what we call your atomic number, and what did we say the atomic number is? That's the number of protons. And so depending on your atomic number, the number of protons, this determines your identity, and it also determines this organization of your electrons. And in the previous video, I was talking about sodium, because of its atomic number, had only one electron in that outer shell, and chlorine, because of its atomic number, had 7 electrons in its outer shell, outer orbit. And we had said a way that those two atoms could fulfill the rule of 8 and gain stability was by the sodium giving away an electron to the chlorine. And that produced what we called ions, cation and anion. Now, if you are something like carbon, carbon has a atomic number of 6. And so we said you've got 2 electrons in that real low energy orbit. We don't care about those. And that leaves 4 more. We had said 6. 2 plus 4 equals 6. It's simple math. And so the outer shell would have 4 electrons. And so it's difficult. You can't really give away 4 electrons, and no one's going to give you 4 electrons. So you have to have another mechanism for these kinds of atoms to achieve stability. And that is what we call covalent bonding. And this covalent bonding, I didn't write it up here, I'm going to write it, is an alternative way to fulfill the rule of 8s. And this is where you share pairs of electrons. The name is covalent bonding. All right, I meant to write that on the board. This is what we're talking about. Covalent bonding is sharing pairs of electrons. And so if we look at a different example, so what about chemical formulas? You might say you don't know any chemical formulas, but you actually do. There's one that everyone knows. It's synonymous with water. Water, H2O, right? Everyone knows that. What are you saying? When you say H2O, you're saying H2. H is hydrogen, O is oxygen. 2 hydrogen atoms, 1 oxygen atom. Okay, so we had said carbon, hydrogen, and oxygen are the most common chemicals in biological chemicals. So if we look at hydrogen, the atomic number is 1. That means it has 1 proton and 1 electron. Oxygen, on the other hand, the atomic number is 8. That means it has 8 protons. And again, we have these 2 inner electrons. We don't care about them, except that it tells us that the outer orbit will only have 6. 2 plus 6 is 8. Another simple math problem. But so what happens, rather than anybody giving away electrons and receiving them, it ends up you can gain stability by just sharing a pair of electrons. And we said this stability is what we're talking about when we say 2 hydrogens and an oxygen coming together forming water. They gain stability, and so you get the substance called water. So what happens? So you have 6 outer electrons, and you're going to have 2 hydrogens. And so I've drawn this funny little shape over here. You see that 8 there? That's referring to the atomic number of oxygen. So 8, that's oxygen with the that needs the 2 outer electrons. And each of these single P's is referring to hydrogen. And the line that's between them, this is what we would call a chemical bond. and it is a pair of electrons that can go from here up to here, or another pair of electrons that are shared between this hydrogen and this oxygen. So you have a pair of electrons that are shared between these two, and another pair of electrons that are shared between those two, and it fulfills the rule of 8. So this is covalent bonding. Now, I'm going to stop right here because I'm going to draw another picture of water like this, and I'm going to draw a picture of methane. Everyone's favorite chemical, right? Natural gas. No, but there's a reason for that. And so we'll come back and I'll continue talking about 2 different forms of covalent bonding. Covalent bonding, remember, is not giving away an electron, it's sharing pairs of electrons. All right, that's next.